So this is the question number 8, exercise 5.2 pertaining to arithmetic progressions, that is AP. This says an AP consists of 50 terms, of which third term is 12 and the last term is 106, that is 106. Find the 29th term. In this case we have to find a 29 is equal to how much. So we have been given n is equal to 50, that is 50 terms. Third term is given as 12, that is A3 is given as 12, and A50, that is the last term, is 106. We know in an AP series nth term is given, an is given as a plus n minus 1 into d. So this formula we will use. So it means a3 is equal to a plus n is here a3, that is third term, n is 3 minus 1 into d, or a3 is given as 12 is equal to a plus 3 minus 1 2, so 2d. This is equation 1. Now second case, we have been given a50 is equal to a plus n is 50 minus 1 into d, or a50 is given as 106, or 106 is equal to a plus 50 minus 1, 49d. Let it be equation 2. Now we have two equations and two unknowns, that is a and d are unknown, so we can find out the values of a and d from here. So from equation 1 we can say, from equation 1 a is equal to 12 minus 2d, and this is the value of a will put in the equation 2, and on putting the value of a in equation 2, what we get in equation 2? Equation 2 is 106 is equal to a plus 49d. So a is how much? 12 minus 2d. 12 minus 2d plus 49d, or this is equal to 106 minus 12 is equal to minus 2d plus 49d, that is 47d. So d is equal to 106 minus 12, that is 94 by 47, so that is equal to 2. So d is equal to 94 by 47, that is equivalent to 2. Now we will put the value of d in any of the equations, that is 1 and 2. We will be getting the value of a. Now on putting the value of D is equal to 2 in equation 2, we get, so equation 2 is nothing but, equation 2 is 106 is equal to A plus 49D. 106 is equal to A plus 49D, or 106 is equal to A plus 49 into D is 2, or A is equal to 106 minus 49 into 2, that is 98, or A is equal to 106 minus 98, that is 8. Now we have the value of A and D. So we have to find the value of 29th term, that is A29. As we have to find the value of A29 and A20, and we know AN is equal to A plus N minus 1 into D. So A29 is equal to A is how much? 8 plus N is 29 minus 1 into D is 2. So this is equal to 8 plus 28 into 2, so that is equal to 8 plus 56 is equal to 64. So A29 is, that is 29th term is 64. The value of 29th term is 64, which we have to find out, and this is over now. This is question number 9, exercise 5.2, pertaining to arithmetic progressions, that is AP. This says if the third and ninth terms of an AP are 4 and minus 8 respectively, which term of the AP is 0? So in this case, what we have been given, a third and the ninth term we have been given, so that is A3 is equal to 4 and A9 is equal to minus 8. And we have to find the value of n, which gives us 0 value. So from here we know the formula that An is equal to A plus N minus 1 into D. By using this formula, we will know A3 is equal to A plus, so N is 3 minus 1 into D, or A3 is given as 4 is equal to A plus 3 minus 1 to 2D. So let it be equation 1. Similarly, we have been given as A9 is equal to minus 8 and A9 is equal to A plus 9 minus 1 into D, or A9 is minus 8 is equal to A plus 9 minus 1 8D. So let it be equation 2. Now we have two unknowns and two equations. Two unknowns are A and D. We will find the value of A and D from equation 1 and 2. So from equation 1 we will put the value of A equal to 4 minus 2D in equation 2. So from equation 1, we get A is equal to 4 minus 2D. A is equal to 4 minus 2D, which we can put in equation 2. So equation 2 is, that is, minus 8 is equal to A plus 8D, or minus 8 is equal to A is 4 minus 2D. We will put the value of A as 4 minus 2D plus 8D is given as it is, or minus 8 is equal to, or minus 8 minus 4 we are bringing on the left hand side, gives us minus 2D plus 8D, that is 6D, or 6D is equal to minus 8 plus minus 4 minus 12, or D is equal to minus 12 divided by 6, that is minus 2. Now we got the value of D, and we will put the value of D in equation 1 or 2, and we can get the value of A. So on putting the value of D in equation 1, on putting the value of T is equal to minus 2 in equation 1, we get so equation 1 is 4 is equal to A plus 2D. This is equation 1. So, or 4 is equal to A plus 2 into D is minus 2, or 4 is equal to A plus 2 into minus 2, that is minus 4, or A is equal to 4 plus 4, that is 8. So we got the value of A and D. Now we have to find out the term which is equal to 0. So let us assume that nth term is 0. and nth term is given as an is equal to a plus n minus 1 into d, or if this is 0 nth term, so then we have a is equal to 8 plus n minus 1 into d is minus 2, or minus 8 is equal to n minus 1 into minus 2, that will give us minus 2n, and minus 1 into minus 2, that gives us plus 2, or we will be getting minus 8 plus 2 we will bring on the left hand side, this becomes minus 2 is equal to minus 2n, or minus 10 is equal to minus 2n, or n is equal to minus 10 divided by minus 2, that is 5. So it means fifth term so it means fifth term of the AP series is 0, where an is 0 when n is equal to 5. So this we have to find out, and this is over now. So this is question number 10, exercise 5.2 pertaining to arithmetic progressions, that is AP. This is the 17th term of an AP. This is the 17th term of an AP exceeds the 10th term by 7. Find the common difference. So here we have been given a 17th is equal to a 10, that is 10th term, plus 7, that is 17th term is equal to a 10th plus 7, as it exceeds a 17. So this is a 10 plus 7. Now we know the nth term is given as an is equal to a plus n minus 1 into d in the AP series. So we'll put the values as a 17 is equal to a plus 17 minus 1 d, or a 17 is equal to a plus 16d. This is 1. Then a 10 is equal to also a 10 will be equivalent to a plus n minus 1, that's 10 minus 1 d, or a 10 is equal to a plus 10 minus 1 9 d. So we will put the values of 1 and 2 in equation A. That will be equation 1. So on putting the values of now on putting the values of A17 and A10 from equation 1 and 2 into equation A, we will be getting A17 is equal to, A17 is how much? A plus 16D. So A plus 16D is equal, A17 is equal to A10 plus 7. So A10 is how much now? 9, A plus 9D, A plus 9D plus 7. So we will be getting A and A will get cancelled, or A plus 16D minus A minus 9D is equal to 7. So A minus A is 0, 16D minus 9D, that is 7D is equal to 7, or D is equal to 7 by 7, that is 1. So we have to find the common difference. So this is common difference, hence the common difference is is equal to 1, which we have to find out, and this is the answer. Question number 11, exercise 5.2 pertaining to arithmetic progressions, that is AP. This says which term of the AP, that is 3, 15, 27, 39 and so on, will be 132 more than the 54th term. So it means here, okay, first we will take what is given here. AP series is 3, 15, 27 and 39. So A is equal to 3, D is equal to 15 minus 3, that is 12. And let the nth term be more by 132, then it's 54th term. So in this case, what is given, that which term of the AP will be 132 more than its 54th term. So let it be nth term, which is more by 132 than its 54th term. It means an is equal to a54 plus 132, because this is a nth term which is more by 132 than its 150 and then its 54th term. So it means an is equal to a150. It means an is equal to a54 plus 132. Now an and a54 will put the values. An is given as, we let it call it equation 1. So an is equal to a plus n minus 1 into d is 12 into 12, and a is given as 3. So we'll put the values of, so let it call it d. So which is equivalent to 3, a is 3 plus n minus 1, n we don't know, we have to find out, into d is given as 12, or this is equivalent to 3 plus 12 n minus 12, which is equivalent to 12n minus 9. So an is equal to 12n minus 9. And a54 is how much? Similarly, a54 is equal to a plus n minus 1 into d is equal to a is given as 3 plus n minus 1 into d is 12, or this is equivalent to 3 plus n minus 1 into 12, that will give us 12n minus 12, or which is equivalent to 12n minus 12 plus 3, that is minus 9. So a54 is equal to 12n minus 9. Sorry, n is 54 here. So in this case n is 54. So this is 53, 54 minus 1, 53. So 53 into 12 will give us 'So a54 is equal to 3 plus 54 minus 1 into 12, which is equal to 3 plus 53 into 12, which is equal to 3 plus 53 into 12, 12 into 3, 36, 3 remainder, 12 into 5, 60 plus 3, 636, that is equivalent to 639. So now we will put the value of an and a54 in equation 1, where an is equal to a54 plus 132. So on putting the values of an a54 in equation 1, we get an is equal to a54 plus 132. This is equation 1, and on putting the value of an is equal to, we'll put the values. An is equal to 12n minus 9. An is 12n minus 9 is equal to a54 is how much? 639 plus 132, or 12n is equal to 639 plus 132 plus 9, or 12n is equal to 639 plus 132 plus 9. So this is equivalent to 9 plus 2 11 plus 9 20 2 3 5 5 plus 3 8, and here we have 1 plus 6 7. So this is 780. So n is equal to 780 divided by 12. So 12 6 is 72. We are left with 60. So 12 into 5, 60. So n is equal to 65. So this is the answer which you have to find out. So this is the answer, n is equal to 65, which says that the term 65th term is more by 132 from its 54th term in the given series. So this we have to find. This is over now.